So we are going to talk about the relationship between demand, linear demand, elasticity, and the marginal revenue of a linear demand curve. Okay, but before we do that, we need to do some background work. So let's first talk about marginal revenue and demand. Okay, first of all, marginal revenue. Let's define that. Marginal revenue is the additional revenue that comes about due to a change in output. Remember, the word marginal means additional. So marginal revenue is the change in total revenue divided by, or that comes about because of a change in quantity. Okay, and it's going to be useful to us to derive the marginal revenue from the inverse demand curve. Remember, the inverse demand curve is the one where price is the dependent variable and quantity is the independent variable. Okay, so we rearrange the demand curve from the behavioral response, which is quantity demanded, as a function of price. So it's just an algebraic rearrangement. Okay, so let's think of the inverse demand curve as price as a function of quantity. And I'll make that clear by putting it up here. Okay, so in that case, total revenue is equal to price, which is a function of quantity, price times quantity. So marginal revenue is a change in the product of price and quantity divided by the change in quantity. Okay, so since total revenue is the product of price and quantity, then marginal revenue, if we use some calculus, recognizing that as we go from discrete changes, these triangles, to small changes, okay, we just move a little bit into calculus, we can derive what that relationship is. Okay, so the change in total revenue divided by the change in quantity, I think we'll use what's called the product rule for derivatives. And that, the product rule means that you take the first derivative of the first term of a product, multiply it by the second term, and then add the derivative, or add the first term multiplied by the derivative of the second term. Okay, so the derivative of the first term is dp dq, or the slope of the inverse demand curve, the change in the price divided by the change in quantity multiplied by the quantity. And then we add to that the first term, which is price, and then the derivative of the second term with respect to q. So dq dq, the change in q divided by the change in q, which is equal to dp dq plus p. Okay, and one thing that you can determine from this relationship is that marginal revenue will always be less than price if the demand curve is downward sloping. And that's because since dp dq, this is the slope of the inverse demand curve, because of the law of demand, the slope is negative. So a negative number multiplied by a positive number is a negative number. Okay, so since this first term is negative, then marginal revenue is going to be less than price. Okay, so that's some insights from calculus, but we are going to always use this linear demand curve. Okay, and so when you use a linear demand curve, the calculus becomes a lot easier. Okay, so let's just use a real simple example. Here we have a demand curve where quantity demanded is equal to 6 minus price. Okay, so we have a slope of this demand curve is equal to 1. Okay, and so the inverse demand curve is just price equals 6 minus Q. Okay, so the total revenue is price as a function of Q, price times quantity. Okay, so if we take price, the right-hand side of price, 6 minus Q, and multiply that by quantity, we have an expression, mathematical expression for total revenue. And multiplying quantity through, that's equal to 6Q minus Q squared. So the marginal revenue is the first derivative of the total revenue function. And if we just use the product rule, which we talked about in chapter 1, then that's equal to 6 minus 2Q. Okay, so we can see that the marginal revenue, which is 6 minus 2Q, is going to be always less than price, which is 6 minus Q, because we're subtracting a larger number, 2 times Q, from 6 with the marginal revenue function than we are with the inverse demand function. Okay, so that gives us this graph. So the demand curve, if the inverse demand curve is 6 minus Q, then we have both a vertical and a horizontal intercept of 6, and the slope is minus 1. Okay, and then the marginal revenue function, marginal revenue curve, marginal revenue equals 6 minus 2Q, and when marginal revenue is equal to 0, if you plug in 0 on the left-hand side, then 0 equals 6 minus 2Q. Subtract 6 from both sides, so we have minus 6 equals minus 2Q, divide both sides by minus 2, and marginal revenue is equal to, or quantity, when marginal revenue is 0, quantity is 3. Okay, so I can punch in a 3 for the point where marginal revenue strikes the horizontal axis. Okay, and just for example, at a quantity of 1, so when quantity is 1, 6 minus 1, price is equal to 5, and on the marginal revenue curve, when quantity is 1, 6 minus 2, marginal revenue is 4. So marginal revenue is always below price. Okay. And so that is a building block, a foundation that helps us understand the relationship between marginal revenue and the own price elasticity.